Part 3, Algebraic Solutions of Inequalities. Solve the rational inequality x minus 2 over x squared minus 16 greater than 0 algebraically. We're going to use a sign line to do this. My first step will be to factor both the numerator and the denominator if they are not already factored. So I have x minus 2 over x plus 4 times x minus 4 greater than 0. Then think about the graph of a rational function. The places where the graph might change from positive to negative would be at the x-intercepts and at the vertical asymptotes. So all of the zeros of the numerator and denominator are what we're going to put on our number line. So 2, 4, and negative 4. 2 is a zero of the numerator, 4 and negative 4 are the zeros of the denominator. So I have different intervals. I have an interval from negative infinity to negative 4, from negative 4 to 2, from 2 to 4, and 4 to infinity. I'm going to pick a number in each interval to decide if the graph will be positive or negative in that interval. So if I pick a number, say less than negative 4, let's try negative 5. If I plug in negative 5, I would get negative 7 over negative 1 times negative 9, and 3 negatives means that's negative. If I plug in a number between negative 4 and 2, say 0, I would get negative 2 over 4 times negative 4, and 2 negatives make a positive. Notice I don't really care what the number is. I just care if it's positive or negative. Between 2 and 4, I might try 3, and I would get 1 over 7 times negative 1, so 1 negative. And bigger than 4, I might try 5, which would be positive over positive, which would give me positive. Now I want greater than 0, so negative 4 to 2 and 4 to infinity are where this graph is above the x-axis or where the function is greater than 0. Let's try another one. Solve the rational inequality x plus 1 over x minus 2 less than or equal to 3. The first thing I'm going to do is get everything on one side of the inequality and 0 on the other side. If it was an equation, I might just multiply both sides by x minus 2, but with an inequality, that makes it difficult. I don't know if x minus 2 is positive or negative. It depends on what x is. And if I multiply both sides by a negative, then I would have to switch the direction of the inequality. So instead, I'm going to get 0 on one side and then find a common denominator. So my common denominator will be x minus 2. And then I will simplify and refactor the numerator if necessary. So I have x plus 1 minus 3x plus 6 over x minus 2 less than or equal to 0, or negative 2x plus 7 over x minus 2 less than or equal to 0. Okay, the zeros of my denominator is 2, and the 0 of my numerator is 7/2. And again, I need to pick values in the different intervals to decide where the function is positive and where it's negative. If I pick to the left of 2, say 0, I get 7 over negative 2, which is negative. Now, because all of my factors have odd multiplicities, we are going to go back and forth between positive and negative. Think the numerator gives us our x-intercept, and if it's an odd multiplicity, we cross through the x-intercept, so it changes from negative to positive or from positive to negative. Same thing with the vertical asymptote. If that factor is an odd multiplicity, then the graph will on one side be going up toward positive infinity, on the other side going down toward negative infinity. So if all of my factors have odd multiplicities, the graph will be going back and forth between positive and negative. Now I want to know where it's less than or equal to 0. So that would be negative infinity to 2, unioned with 7/2 to infinity. But I need to decide on the 2 and the 7/2 whether to put parentheses or bracket. So x minus 2 is our denominator, so I cannot include 2. But the 7/2 is the 0 of the numerator, and the numerator can be equal to 0, so I'm going to include 7/2. Solve the rational inequality 3 over x minus 2 less than 2 over x minus 3. Again, I want to get everything on one side, so I'll subtract 2 over x minus 3. And then I need to find a common denominator, which would be x minus 2 times x minus 3. So I have 3 times x minus 3 minus 2 times x minus 2 all over x minus 2 times x minus 3 less than 0. If I distribute through that numerator, combine like terms, and refactor whatever I need to do, I end up with x minus 5 over x minus 2 times x minus 3. And go ahead and check that algebra for yourself. So my 0 of the numerator is 5, zeros of the denominator are 3 and 2. And again, I can plug in values. If I plug in 0, that's to the left of 2, I would get negative 5 over negative 2 times negative 3. So 3 negatives make it negative. If I plug in, say, 4, that's between 3 and 5. If I plug in 4, I would get negative 1 over 2 times 1, so it's negative. And because, again, all of my factors have odd multiplicities, I know I'm going back and forth between positive and negative. This time I want less than 0, so negative infinity to 2, and 3 to 5. And I don't have any brackets because I don't want less than or equal to 0, just less than 0. Solve the rational inequality 12 divided by x squared minus 5x minus 6 greater than or equal to x plus 2 over x squared minus 1. So I need to factor everything and get everything on one side of that inequality. So I have 12 over x minus 6 times x plus 1 minus x plus 2 over x plus 1 times x minus 1 greater than or equal to 0. Find a common denominator, which would be x minus 6 times x plus 1 times x minus 1. So for the first fraction, I still need the x minus 1. The second fraction, I need the x minus 6. And my denominator is x minus 6 times x plus 1 times x minus 1. Distribute through, combine like terms, and I would get negative x squared plus 16x over x minus 6 times x plus 1 times x minus 1. And again, I encourage you to do all of that algebra, distribute, combine like terms, and make sure we have this. Then I'm going to factor the numerator, so I'll factor out a negative x, and I get negative x times x minus 16 over x minus 6 times x plus 1 times x minus 1 greater than or equal to 0. So this time I have a lot of numbers to put on my number line. I have several intervals here. So we have negative 1, 0, 1, 6, and 16. So the zeros of the numerator are 0 and 16. The zeros of the denominator are 6, 1, and negative 1. So I have several intervals here. Let's start plugging in some points. Let's say between 1 and 6. Let's plug in 2. Then I would get negative 2 times negative 14 over negative 4 times 3 times 1. So 3 negatives make that negative. Between 6 and 16, let's say I plug in 10. If I plug in 10, I would get negative 10 times negative 6 over 4 times 11 times 9. So 2 negatives make that positive. And again, I'm going to go back and forth between positive and negative because all of my factors have odd multiplicities. If I had a factor with an even multiplicity, let's say it was x minus 16 squared, then on both sides of 16, it would be the same sign. Or you can just check a number in every single interval if you'd rather. Here I want greater than or equal to 0, so negative infinity to negative 1, parentheses on the negative 1 because negative 1 comes from the denominator and the denominator cannot be equal to 0. Union 0 to 1, bracket on the 0 because that's the 0 of the numerator, parentheses on the 1, and then union with 6 to 16, and the bracket goes on the 16 there.